All right, guys, so today and Monday we're going to look over the review sheet. So we'll go a little bit more in depth than we normally do because we're going to split it across 2 days. Yeah. Yeah, no, the final for this class is Tuesday. It's been set there, so I've been kind of stretching things out to make it there. Now, when we look at problems 1 through 5, really when we evaluate these functions for the given values of x, we're just plugging them in. So we could look at number 1. So 16 to the negative 2 plus 5. Yeah. 1,000. And at this point here, really, we can just type that into the calculator, and it'll tell us what it is. The same is true for when x is 3. It would be 16 to the 3 plus 5, which is going to be this big number here. So really all we have to do for these here is plug them into the calculator to get our answer. So any questions on any one of these in particular? Now on some of them, if you get a decimal answer, that's fine. I will check the decimal answer because I think on number 5, for one of them, I think it was when x is 3, most of y'all got a decimal answer and it said a fraction. I'll check it and make sure it's the exact same, because I'll take the decimal version or the fractional version. It doesn't matter which one you give me as long as it is the correct answer. Any questions on these here? Six through 11, tell whether the function represents exponential growth or exponential decay. So the first one would be growth, because the base is greater than 1. The base is less than 1 but greater than 0. The base has to be between either 0 or 1 or greater than 1. If it's greater than 1, it's growth. If it's between 0 and 1, it is decay for these 3 here, 6, 7, and 8. Now for 9, 10, and 11, we're really looking at the exponents, because when we have a base of e, we're focused on the exponents. If the exponents are positive, then it is growth. If it is negative, then it would be decay. So for number 9, it would be growth. Because really the reason it is decay for number 10 is, what we can really write this as is 9 times 1 over e to the 7th to the x. So this here becomes between 0 and 1. Is really the reasoning behind that. So for 12 through 19, we want to rewrite each logarithm as an exponential. Now the way we went over this originally was that log base b of x is equal to y, if and only if b to the y is equal to x. And we went through changing this and going through this property here. But really what we can do is apply the base to both sides. So here the base is 9. 6,561 is equal to 9 to the 4th. And that's it. And the reason that we didn't do this for the get-go is because we didn't know at that point that 9 to the log base 9 would simplify out, that would cancel out. But now that we do know that, we can use that property to simplify these. And for this one here, we can use 5 and, because these will cancel, and we have 5 to the 7th is equal to 78,125. And we have this here. And the nice thing with these here is if we're not sure that we did it correctly, we can always do 5 to the 7th in the calculator, because these are all just numbers. And if 5 to the 7th does equal 78,125, then hey, we have the correct answer. Any questions on any others of these up here? We're good with these here. Since it's understood that the base is e, these would cancel, telling me that e to the 7th is equal to x. So could I plug this one in the calculator to check it? Not really, because do we know what the value of x is? No. So these here, we can't really check them. And again, I stuck with x because e to the 7th, is that going to be a nice, quote unquote, nice number? No. E is a non-repeating, non-terminating decimal. It's irrational. So there's no way that I could actually write this and get a nice number for x of what's inside the log without approximating it. So I just put it as x. So most of the ones, especially on the test, like on the review, when we deal with the natural logs rewriting them, I'll put variables in. So they're a little bit more accurate and not rounded. Any questions on these here? Which one? 19? Yeah, and that works too. Because I get some of these flipped, ironically. I believe it's the commutative property of equality. It says A is, let's see here, no, it's reflexive. Reflexive property of equality, A is equal to B is the same as B is equal to A. We can flip them because they're still saying that they are equal. They're still equal to each other. So the order in which we do them really doesn't matter. I just like having the variable on the left-hand side. Personal preference. So any other questions on these here? You feel good with these here? All right. 20 through 25, so we're going the other direction this time. Now, right, we can apply log base 3 to both sides, which these will simplify. 4 is equal to log base 3 of 81. Or we could say that log base 3 of 81 is equal to 4. We can go in either direction. We can have it written either way. And again, now that we know that the log base 3 of 3 really cancels out, we don't have to use that kind of switching property. We can apply these here. Any questions on either one of those or that first one? 23, 24, 25, which one of those do we want to look at? 25. So with this one here, really, we can apply ln, because ln of e to the x would be x is equal to ln of y. So we can apply natural log to both sides, and really, it ends up rewriting it as a logarithmic. That's all we have to do with these here, because we can do it with any of them. ln y equals ln of 7. Questions on this here? Be ready for the next one. Evaluate each log and round to 3 decimal places. I'm not going to be absolutely strict on this here like Big Ideas is, because Big Ideas, I think for some, I don't know if it's in here, counted off or counted it wrong if you didn't round the actual 3 decimal places. So for this one here, log base 5 of 1 over 125, it is -3, yes? You will get that right if you put -3. But Big Ideas Math would have counted that wrong, because it wants. For this? Yeah, for some of them, if it asks, because I've seen it where it asks to round to the nearest 100th, 2 decimal places, it was ended up being a 0. They wanted the 0, especially if you round up or down. If you round up and it becomes a 0, it wanted the 0. Because of significant figures, it ends up, if you round up, if it was a 9 and rounds up and becomes 0, they want that 0. Mainly to signify that you've rounded it up. It was 9 and became a 0. Is part of the reason for it. Any of the other ones that we want to look at for these here? Because again, we could type this in, but since it's log base 10, it's the same as log, because our common logs have a base of 10, so we can do log. We don't even have to do the 10. We can just use our log of 0.00001, and it would be -5. Now, why not? Let's get, come on. I'm trying to get, there we go. I was trying to get that to go away so I could, yes. Yes. Oh, thank you. So I'm going to look back at this one here, if we were doing this by hand. Well, we would apply 10 to both sides. These would cancel, 0.00001. 10 to the x. Well, I'm going to scoot around it and use scientific notation, because scientific notation is really, we move the decimal over and multiply whatever number we have times 10 to whatever the power. Since we moved it 5 spaces to the right, it's negative. If we move it to the left, it is positive. Well, 1 times 10 to the -5 is just, or another way we could have done this, let's see here, that's too many zeros. Because we could turn this into a fraction, which would be 1 over 10,000. 1 over 10 to the 5th. Which we can move it up top, 10 to the -5. -5. So there's different ways we can go about doing this. 31. ln of 4 to the 6th. So we could type that straight in, ln 4 exponent 6. So 8 point.
Yeah, I did something wrong first. I got 30.612. And then I had to redo it. I got 6.
So another way that we can actually do this, especially with exponents, our property of exponent says I can move the 6 out front, yes? So we can do 6 ln of 4, which would still give us our 3 point, what is it one more time?
3. Wait, because it's 8. Yeah.
8, 318. You're good. And we can do it in either way. Or if you want to do 4 to the 6th and then take the natural log of it, that works as well. Any other questions on this here? Expanding the logarithms. 33, let's look at it. Now, wind marker back out. Now, the tricky thing with 33 is the fact that we do have 2 that are in the bottom of the fraction. So we're going to end up having 2 negative signs. And as I was thinking about it since we covered this, because when we condensed it, we really got rid of the division property. We didn't really deal with a division. We had negative exponents. Let's do the same way here. The first thing I'm going to do, squared, is I'm going to move everything up. I'm going to move those 2 from the denominator to the numerator. I'm going to move everything to the top. Because when we move something from the bottom of the fraction to the top, the exponents become negative, which is fine. And now I have 4 things being multiplied together inside the log, so we can use our multiplication property. Log of 7 plus log of x squared plus log of y to the negative 3 plus log of z to the negative 2. So we split them up with addition. Questions on this here? Now we can use our properties of exponent, so we take the exponent and throw it out front. Well, log of 7 is not going to change. But then we have plus 2 log of x minus 3 log of y minus 2 log of z. Because by pulling them from the denominator to the numerator and then using the multiplication property and then our power property, we get the correct signs all the way through. We don't have to worry about negatives and making sure which one's negative, which one's positive, and distributing it. So this makes it a little bit easier to work. Any questions on this here? Mm-hmm. So 34, I would do the exact same thing. 7x cubed times 16 to the negative 1, y to the negative 2. I'm going to pull both of them up. And really, from here on out, when I cover this again next year, I'm going to start doing it this way because it's a little bit easier to work with. We're not having to worry about making sure ln of 16 and ln of y both are negative. Now we can split it up according to our multiplication property. And our exponent property. Got 2. We're going to get there. Minus ln of 16 to and I will take this here. And I think that's what the back of the answer key says. Yep. Because, I mean, if we wanted to 16, I could break it down farther. Because 16 is 4 squared, so we could have 2 ln of 4. Or really, 16 is 2 to the 4th, so we could have negative 4 ln of 2. Because we can keep simplifying that down, but I'm not going to worry about that. I'm not going to have you worry about making sure all of them are prime. So getting at least this far is where I want you to get it to. Any questions on these here? Condensing. Any one of these in particular y'all want to look at? 37? So when we look at this here, the first thing we need to do is our exponents. So we're going to pull the number out front back up into the exponent. And you can write it below. I'm not going to have enough space. X to the 9/7 plus 4 of y to the 9th. Now, because these two are added together, I can rewrite it as 1 log, with these being multiplied. And that's it. And I think that's what the answer key says, because I don't know if I rewrote it in radical form. Yep, that's it. Because, I mean, if we wanted to, we could rewrite x as the 7th, or x times the 7th root of x squared, or we can write it as the 7th root of x to the 9th in our radical. But we'll leave it as this here. Mm-hmm. So when we look at 39, again, the first thing I'm going to use is our power property, which will give us ln of x to the 2/3 plus ln of 27 to the negative 5/3. Now, because they're added together, we can rewrite it as multiplication. Now we do need to move the 27 down to the denominator to make it positive. And I have a feeling it's not 27 to the 5/3 in the back. Huh? 27 is 3 to the 3rd, because 3 times 3 is 9, times 3 is 27, which is to the 5/3, because 27 is 3 to the 3rd, then to the 5/3. Powers of powers multiply. Well, 3 and 3, well, 3 over 1 times 3/5. Well, the 3 and 3 would cancel, leaving me 3 to the 5th. And 3 to the 5th is to what? Or actually, if you put 27 to the 5/3, it would actually simplify to 243. Does that make sense on how that one changed? So on some of them, especially on the test, if you do have a number to an exponent, might just go on and check it in the calculator. See if it would simplify, if it will reduce to a number. If it reduces to a decimal, leave it be. If it reduces to a whole number, change it. Questions on this here? Are you good with this here? Any other questions on these here, condensing? We good with condensing? 40 through something. 50. 40 through 50. I turned away before I could read the rest of it. That leaves us with 64. All right. We'll do 2 more and then we'll leave the rest for Monday. So looking at 40 through 50, is there any one of those in particular y'all want to look at? 46. Huh? We can look at it next, so we'll finish it off on those. So with this here, the bases are different, yes? Now, luckily for us, the variable is only one side. It makes it a little bit easier to solve. If you take college algebra, there's a chance that they'll have variables on both sides. We'll have to do a few more steps. Now, for this here, to get the x out of the variable, x out of the exponent, not variable, we're going to put both sides to the log base 11. Is the log base 11 of 11 cancels out, leaving us with 6x plus 2. And the real reason it cancels out is we move that exponent out front, and log base 11 of 11 is 1. So it just leaves us with 6x plus 2 is equal to log base 11 of 38. And when you're typing it in the calculator, make sure that 38 is in parentheses. Because otherwise, if we add or subtract anything, it will apply it inside. Yes. Subtract 2 from both sides. Tell us that 6x is equal to log base 11 of 38 minus 2. Divide both sides by 6. And x is equal to log base 11 of 38 minus 2 divided by 6. 0.81. Negative 0.081. Of 38 minus 2. Yep, negative 0.081 because we rounded up. Yep, and that's it. If you put negative 0.0805 or however you want to put it, that long decimal without rounding, I'll take any version of those. Any questions on this here? I would make sure, especially, to have this written out, x equals, because I will look at that and see also, because if for some reason you typed this into the calculator wrong and got this incorrect, if you have this one set up correctly of what you're actually plugging in, I will give you the credit for it, because then it's just calculation error. That's not actually solving it, because I'm wanting you to solve it. This is solved, but if you plugged it in wrong, but you have it actually solved correctly, you will get the points. Does that make sense? And then 43, 2e to the x minus 7 equals 5. I'm going to write it here. Y'all can do it.
I just did it.
Do you need to see how it's done?
You plus 7.
So plus 7, 2e to the x is equal to 12.
And then you just put the log. That equals 1.7.
That's all we'd have to do for this one here.